So templates are they're both forms of what's considered what's called at a high level generic programming. So there are several different ways you can do generic programming, and templates and .NET generics are two examples of it. In the template case, you've got all of your specialization happening at compile time. In the generics case, you've got all of your specialization happening at runtime. So that's really the fundamental difference. Based on some other differences in the implementation, there are some other flexibilities that you get in different cases. For example, generics allow you to constrain your type parameters in various ways. For example, by saying what they can have what they must have inherited from in order to be used. In the template case, you can actually do all sorts of interesting specialization, where you can say, I'm going to provide a special implementation if you happen to provide this type parameter, or if you provide, in the case of like partial specialization, I'm going to leave some of these parameterized and only specify a couple, and then I'm going to give you a partially specialized implementation just for those cases. So they're really intended to hit different segments. Another difference is that templates can only be used within an assembly. Generics can be exposed outside of the assembly. There are various typing issues that cause that particular outcome. Because it's done in compile time, you actually have to have all your implementation sitting and having been specialized already at compile time sitting in your assembly. So if you've got two implementations in two different assemblies, even if they came from the same template source code, it's really not possible without having considerably more CLR work than we were able to do and probably ever really want to do for this particular space, to be able to determine these two templates actually are semantically equivalent and they are the same type, and that they should be treated that way. And the fact that we can have generics and templates interoperate really solves that problem. If you need to have something exposed outside the assembly, just use a generic interface in order to do it. So what that provides is some very interesting things. In the template case, you can often get better performance for actually specializing computations. So you can do things like high performance computing where you're doing array arithmetic operations, and you specialize these things out specifically for the dimensions of the array that you're using, because you know all that at compile time, and get the best possible implementation, usually often even better than hand-coded C. Because we can do all of these template expansions at compile time. In fact, there's a pretty cool demo that we're probably, if it hasn't been posted publicly already, we'll go ahead and do it, where the Towers of Hanoi, the solution to the Towers of Hanoi is calculated at compile time using templates. Templates are actually a Turing-complete functional programming language. And you can do all that calculation at compile time. Generics, of course, all being runtime, have a different set of limitations and powers, but using them together, you can really get the best of both worlds.
Wow. Do you have that demo?
Not on my machine, unfortunately. It's actually not all that interesting. The way it works is you've got the template code, and then I guess it is kind of interesting. You hover over in the IDE, and it pauses for a second as it does the calculation, and then in IntelliSense, you get the result. Because IntelliSense also is now template aware. So, and can handle all the template calculations since it's entirely a compile time thing. So that's something, it's just a C++ project file that we can post.
But I mean, that could be extended to do even other interesting things for the IDE, for the IntelliSense operations. I mean,
it could be. It turns out that for most IntelliSense things, it actually makes more sense just to implement it with new IDE IntelliSense code. Because doing template expansions and optimizations isn't necessarily going to be as efficient as what the IDE can do directly when it knows a little bit more about the specific problem.